Tomorrow we're going to be taking the PowerSchool test once again to hopefully improve from our previous grade. And before we do, I want to go over those test questions with you, show you exactly what the ropes are, how to do them, so that you basically are ready to take it tomorrow. And of course, you can improve your score. So this is a complex numbers PowerSchool test, and to be fair, not every question here is a complex number question, but it is still, I guess, part of that standard. So we'll go one by one. Hopefully it won't take too long, but some of these questions are pretty elaborate, but I'll try to move through them swiftly. And let's go ahead and begin. So this first one, these are in no particular order, by the way. It says which is equivalent to. And I'm going to rewrite this just because it's kind of blurry on the screen because I had to blow it up some. All right, but it's 5 minus 4i plus 2 minus 3i. Now, the parentheses are not necessarily the most important thing here. The parentheses are just surrounding complex numbers. It's kind of like if you were to write, 6 plus 4 in parentheses. Although the parentheses are not necessarily required, you can still add these together and get 6 plus 4, which is still 10. That's kind of the same idea here, so don't be confused by those parentheses. They're not exactly necessary. They're just telling you basically what those numbers are individually. So anyway, what are we doing here? What does it mean, which is equivalent to? Well, the mathematical operation right here is telling us that we are adding. So that means we're adding these complex numbers together. So really, in a sense, all we're doing is combining like terms. Another way you can think about this problem is, we add things horizontally, like that 6 plus 4 a moment ago, but we can also add things, vertically. We have 5 minus 4i, and then we're adding 2 minus 3i, right? So you can sort of think of it like that. And then you're just kind of adding those like pieces together. Negative 4i minus 3i is negative 7i, and then 5 and 2 makes 7. So you can add them like that if it helps. You've got those two different things. Vertically might be one thing, but how I've been teaching it in class, it wasn't necessarily like that. I've just been saying, hey, let's just combine the like terms. So if you're more familiar with that, more comfortable with that, it's fine. But we have 5, and we have 2. If I were to combine the 5 plus 2, of course I get 7. And I also have my negative 4i plus my negative 3i. And adding two negatives is going to come out to be, I'm going to leave it blue, negative 7i. So it's the same either way. I don't care how you prefer to do it, if you line them up vertically or not. But you should get the same answer because all we're doing is combining like terms. So our answer there was A. And again, the answer choices are also in no particular order, but I guess it was A in that case. So, number 2, what is a solution set? So basically when it's saying that, it wants us to solve this. So let me go ahead and write it down again, because it is a little bit blurry. Plus 20 equals 0. Now there's actually 2 ways of solving this. Factoring would be the easier way, if you can remember how to factor. But we're going to stick with the quadratic formula, because it's going to kind of fit the theme of all these other questions. So quadratic formula is negative b plus minus square root of b squared, minus, not plus, so minus 4 times AC, all divided by 2 times A. Alright? And in the equation, we can find the A, B's, and C's. So our quadratic is always written as ax squared plus bx plus c equals 0. So A is the number in front of x squared, and that number that you don't see is technically a 1. So A is equal to 1. B is the number in front of x, which in this case is negative 9, so B is a negative 9. And C is the last number there, the 20. Alright, so we're just going to plug in those 3 values into our formula and get on with it. So negative b. Now b is already a negative number, so technically I have a negative 9. Okay, the negative that's from the formula, and then the negative that's part of the b value. So I'll go ahead and simplify that in the next step. That'll become a positive in that eventually. But let's go ahead and just keep plugging things in. Now I have b squared, which is negative 9 squared. And what I would prefer to do is wrap that in parentheses, because if I don't, and I try to use my calculator will give me the wrong number, because that should become a positive 81, not a negative 81. that will make a big difference in the outcome of your problem. So make sure you use parentheses when you square something like that. All right, 4 times a, which is 1, times c, which is 20, and then all divided by 2 times a, which is 1. So if I just start simplifying, I'll go ahead and change that to a positive 9. The inside the square root, negative 9 squared is a positive 81. And then 4 times 1 times 20. 4 times 1 is 4. 4 times 20 is 80. So we'll have minus 80. All divided by 2 times 1, which is 2. So if I just continue simplifying the inside of my radical, we'll have 9 still, plus and minus still. The 81 minus 80 is just going to be the square root of 1 over 2 right there. All right, now I can just simplify my square root. The square root of 1 is 1, so really it's just plus and minus 1 over 2. And you can separate these two fractions out. You have a plus and minus, which means you have two fractions, one's a plus, one's a minus. So we have 9 plus 1 over 2, and we also have 9 minus 1 over 2. 9 plus 1 is 10, and then 9 minus 1 is 8. So our two answers, 10 over 2 and 8 over 2, would come out to be 5 and 4. So my two answers are 5 and 4, which is answer choice C. All right. Again, just trying to move swiftly. Here we're doing the same thing. What is the solution set? It wants us to solve this quadratic. 2x squared minus 3x minus 2 equals 0. I'm pretty sure this is also factorable. But again, stick with the theme, we're going to use the quadratic formula again here. So the formula, I'll just go ahead and write it down one more time. B squared minus 4ac, all divided by 2a. So what is our a, what is our b, what is our c? A is in front of the x squared, a is 2. B is in front of the x, and it's a negative 3. And the c is a negative 2. So we're going to be plugging in all of these. So negative b, again, since b is already negative, that will eventually come up to be a positive number. So negative 3 would be a positive 3. Yeah, because we have the negative from the formula combined with the negative from the b value. Those two negatives will make a positive. The square root of b squared, again, I'm going to use my parentheses here, so in my calculator, if I am using one, it doesn't make any mistakes. Minus 4 times a, which is 2, times c, which is negative 2. And then all divided by 2 times a, which is, again, 2. So let's just start cleaning it up a bit. The negative 3 will become a positive 3. The square root, negative 3 squared is going to be a positive 9. Let's see, the 4 times 2 times negative 2, that'll be 8. You can probably just type that in the calculator. 8 times negative 2 is a negative 16. It's going to become a plus 16 right there. Because this negative and also this negative will eventually combine to make a positive, so that's why you'll see plus 16. Your calculator will show you that. And then 2 times 2 is 4. So again, if we just continue cleaning this up, let's look inside the radical. My 3 plus minus is still there, but 9 plus 16 is 25. So that's going to be combined to make 25. We'll have 4 in the denominator. And just like the last problem, this is a perfect square. Square root of 25 is just 5, so we'll have 3 plus minus 5 over 4, which you can break into the two fractions. You got the 3 plus 5 over 4, and you've got the 3 minus 5 over 4. 3 plus 5 is 8, and then 3 minus 5 is negative 2. So we're going to have 8 divided by 4 is 2. And negative 2 divided by 4 is negative 1 half, because you can reduce both of these by 2, making it negative 1 over 2, or negative 1 half. So we have 2 and negative 1 half, which is A. Alright, which is equivalent to, so again, let me just kind of rewrite this problem so that we can see it better. 6 plus 2i minus 4 plus 6i. Alright. So what are we doing with them? Well, the math is telling us, it doesn't say it in the problem, but it says it right here. We are subtracting. Now what I like to do, just to make sure I can prevent any from making any mistakes, is I will distribute my negative here. Whenever I have that subtracting, I'm subtracting technically both 4 and the 6i. So distributing that minus sign, that at least reminds me of that, and I don't end up adding 6i by accident. So if I distribute, this is going to stay the same, 6 plus 2y. But the negative on the 4 is going to become a negative 4, and the negative on the 6i is going to be a negative 6i. So just distribute that negative. It makes ways so that you won't hopefully have any errors. And now at this point, we are just trying to combine our like terms. We have a 6 and a minus 4, which would combine to make a 2. And we also have 2i minus 6i, which 2 minus 6 becomes negative 4i. So we got 2 minus 4i. Answer choice A. So keep in mind, if you're adding or subtracting, you're combining like terms. Here I have another problem where I'm going to solve my quadratic. Another problem in which I will use my quadratic formula. So I have x squared plus 5x plus 7 equal to 0. Again, we're going to use that formula. Negative b plus or minus square root of b squared minus 4ac, all divided by 2a. Again, let's just identify what a, b, and c are. So a is the number in front of x squared. There is no number here, but that just means 1. b is 5, and c is 7. Alright, so if we plug it in, we'll have negative b, which is going to be a negative 5. Because b is positive times, the negative in the formula doesn't, there's a double negative, so it is a negative 5. Plus minus the square root of b squared, which is 5 squared. Again, just to be safe, it's probably good to just use parentheses every time so that you don't ever have any issues. But yeah, 5 squared. Minus 4 times a, which is 1 times c, which is 7. And then we put all of this over 2 times a, which is 2 times 1. Alright, now just to clean it up again. So we still have negative 5 plus minus the square root. So 5 squared is 25. And then 4 times 1 times 7. 4 times 1 is 4. 4 times 7 is 28. All divided by 2 times 1, which is 2. Alright, and just like before, I'll clean up what's inside that radical. So I'll still have my negative 5 plus minus, but 25 minus 28 is a negative 3. And we'll have that over 2. Now the issue here is we have the square root of negative 3. So let me take this out into the sidebar for a minute, alright? Let's go. Alright, the square root of negative 3. The issue here is we need to simplify it, but it's a square root of a negative number, which technically is not possible. If you try to do that in your calculator and you got an error message, that's the reason why. You can't take the square root of a negative. So we have to do this kind of by hand, break it up, and simplify it. We're going to use imaginary numbers. So anytime you have the square root of a negative, separate that negative from the number itself. So you're pulling away the negative by calling it negative 1, and then you have your positive 3 off to the side. So it's still negative 3, it's still negative 1 times 3 is still negative 3. But we separated the negatives so that I could have my square root of a positive number. Alright, so anyway, the square root of negative 1 is what we call I, and the square root of 3, we'll simplify it if we could, but that's already a simplified radical, so it's going to remain as a square root of 3. So basically all we did was take the negative out and call it I. So let's go ahead and put this back into our problem. Alright, so we still have negative 5. We still have plus and minus, but we're exchanging the square root of negative 3 for I, the square root of 3. So that's all we've changed. Everything else has stayed the same. It's just that square root that's been changed a bit. Alright, from this point on, you would simplify any further if you could. However, there's nothing else that would reduce or cancel out or simplify or break down. So that's as far as we're going to get. So that's our final answer. So our answer is answer choice A. I don't know if you can see it because of how small and blurry it is, but it's the same process, just had a slightly different conclusion to the other quadratics that we solved. Alright, this one which expression is equivalent to, we have 4 plus 3i over 3, I think, minus 2i. Alright, so the problem here is we have an I in the denominator, and that's what we need to take care of. So what we're going to do is we're going to multiply this by the conjugate of the bottom. So the 3 minus 2i, its conjugate is 3 plus 2i, right? We just basically changed the sign there in front of the I term. So we're going to multiply the top and bottom by 3 plus 2i. Okay, the same thing on both. And again, we find these, the 3 plus 2i, because it's the conjugate of that the denominator. So now we have to multiply these out. So let's FOIL the top. We'll have the 4 times 3, which is going to make 12. The 4 times 2i, which is going to make 8i. The 3i times 3, which would be 9i. And then the 3i times 2i to make 6i squared. Don't forget about the I squared. And on the bottom, we'll do the exact same thing. We'll distribute 3 times 3 is going to be 9. And 3 times 2i was going to be 6i. Negative 2i times 3 is going to be negative 6i. And negative 2i times 2i would be negative 4i squared. Now, before I do anything else, I do have some terms that I will combine, but let me remind you that I squared is equivalent to negative 1. So where I see the I squared here, and I'm talking about this I squared and this I squared, I'm just going to change those into negative 1. Okay? I want to leave everything else the same just so I don't lose you. But all I'm going to do is rewrite this whole thing, but exchange the I squareds for negative 1. So leave the top part the same. We'll have 6 times negative 1. And then the bottom part, we still have 9, 6i minus 6i. But I'm exchanging the I squared for negative 1. Now, just real quick, I'm going to use my eraser tool instead of rewriting this again. But 6 times negative 1 is just going to be negative 6. So I'm just going to go ahead and just replace this with a negative 6. And on the bottom, negative 4 times negative 1 is going to be a positive 4. So I'm just going to exchange that for plus 4. Okay? Just so I didn't have to write it all down again. Alright, and now on the top and bottom we have like terms to combine. On the top, you see we have 12 minus 6, and we can combine 12 minus 6. That would be a regular 6. And we also have on the top 8i plus 9i, which if we combine those would make 17i. And then we'll do the same thing on the bottom. On the bottom we have 9 plus 4, which is going to make 13. And the 6i minus 6i, those actually end up canceling out and becoming 0. So on the bottom we just have 13. So there's pretty much the answer. You'll see on the left that the answer choices are broken up. They'll actually write this as 6 over 13 plus 17i over 13, where they just separate the denominator into 2 fractions rather than having it in 1 fraction. But it's the same result either way, and that correct answer choice is answer choice A. Alright, so this one, we're just solving. Just a regular equation to solve, like any other regular equation to solve. So let me rewrite it first so it's a little less blurry. Alright, we're just trying to get the x by itself. So let's start moving things around and getting that x by itself. So we'll start by subtracting 48. Okay, that'll leave us with 3x squared equals to negative 48. Then we'll divide by 3. It's very important that we divide by 3 in this step. We don't try the square root it yet. We'll have x squared equal to negative 16. And now we'll square root both sides so I can get rid of the 2 of the exponent there for x. So square root of negative 16. Again, we pull this off to the sidebar for a minute. Alright? The square root of negative 16. Remember, you can't take the square root of a negative, so we separate the negative from the number itself. We call the square root of negative 1i, and then we simplify the square root of 16. We know what square root of 16 is. It's 4, right? So this is going to become 4i. Technically, it's a positive and negative 4i. We've talked about that in the past, because when you take the square root, there's technically 2 correct answers. 4 squared is 16, and negative 4 squared is 16. So that's why there's both a positive and negative version of our number. So here's our answer. It's written on the answer choice as 4i and negative 4i. They kind of spell it out differently. So 4i and then negative 4i. So rather than writing it like I wrote it, they wrote it, separately. But it's the same thing. It's a positive 4i and it's a negative 4i. Alright, this one, which is equivalent to 3 plus 4i times 2 minus I. So what are we doing here? Well, we're not adding them because there's no plus sign. We're not subtracting them because there's no minus sign in between. Right? There's no sign in between them, which means we are multiplying them. All right. Now we've already kind of done this in one of the previous questions, but we're just going to multiply these out. So that means distributing. 3 times 2, that's going to get us 6. 3 times negative I is negative 3i. 4i times 2 is 8i, and then 4i times negative I is negative 4i squared. Don't forget, because you have an I times an I, that makes the I squared. Just like the last problem, I remember that I squared is equal to negative 1. So let me just rewrite this whole thing, but change the I squared to a negative 1, just so I can avoid making any mistakes. Right? So I have negative 4, and then times negative 1. So you see, all I've done is change I squared to negative 1. Now I also realize that negative 4 times negative 1 is a positive 4, so I'm just going to kind of go back and fix that as a plus 4. And now it's just a combining like terms decimal. So we got 6 plus 4, which is going to combine and give us 10. And we also have negative 3i plus 8i, which could combine to give us 5i. Negative 3 plus 8 is 5. So we have 10 plus 5i, which is answer choice B in this case. Alright, what are the roots? So again, another problem in which we're using the quadratic formula. So the problem is 2y squared minus 6y minus 3 equals 0. And even though it's the y's instead of x's, it's still the same formula, same quadratic formula. Negative b plus or minus the square root of b squared minus 4ac over 2 times a. So a is still in front of the squared term, it's 2, b is negative 6, and c is negative 3. So let's plug them in. We'll have negative b, but b is negative 6, so we do have that double negative going on, which I will make a positive 6 in a minute. Well, let's continue filling this in. B squared, that's a negative 6 squared, minus 4 times a, which is 2, times c, which is negative 3. All divided by 2a, which is going to be 2 times 2. So if I just clean it up, we'll have a positive 6 here, because a negative 6 makes a positive 6. The square root, negative 6 squared will be a positive 36. 4 times 2 times negative 3, that's going to be 8 times negative 3 is negative 24, be plus 24. Because the minus a negative number will make it positive. Alright, so then we have all divided by 2 times 2, which is 4. So again, if I just go ahead and clean it up, the 36 plus 24 is 50? No, 60, right? Yeah, 60. Alright, so we're going to have 6 plus minus square root of 60 over 4. Now, just like before, we need to simplify the square root of 60. So let me kind of sidebar that up here. 60. Well, 60 is not a perfect square, but we can break it up, right? What are two numbers that multiply to 60? One of them is a perfect square. So remember, the perfect squares are 4, 9, 16, 25, 36, 49, etc., etc. This will break into 4 times 15. 4 times 15 is 60, and 4 is the perfect square that we're using. The square root of 4 is 2, and the square root of 15 is our remainder. That one doesn't change, that one doesn't simplify. So this turns into 2 square root of 15. So we get 6 plus minus 2 square root of 15 over 4. So again, the 6 and 4 did not change, I just changed the square root of 60. Now we're pretty much done, but you see the three numbers that are outside of radical? We have, let me highlight these. We've got the 6, the 2, and the 4. All three numbers can be reduced by the same amount. They are all divisible by 2. So if you divide all of them by 2, 6 divided by 2 will become 3. 2 divided by 2 will become 1. So we'll just have 1 square root of 15. And then 4 divided by 2 will become 2. So here's our answer. And if we look over to the left, we'll see that which one matches this. Positive 3 So it's going to be C. All right. They separated the plus and minus. They have it as 3 plus square root of 15 over 2, and also 3 minus square root of 15 over 2. But that's the same thing as this, except this is written together, whereas their answer choice is just written out. All right, I believe we have one more. All right, we have x squared minus 8x equals 9. The only problem with this is it's not in the correct format. We want this to be everything on one side and then nothing on the other. So we're going to want to move this 9 to that side so that we can have everything on the left and then nothing on the right. So we'll have to subtract 9 to make that happen. So our equation should be x squared minus 8x minus 9 equal to 0. All right, so that's our equation, and now we're going to jump into using our quadratic formula. Oops, not what I wanted to do. All right, let's kind of move this. Oh, come on, man. All right, anyway. I tried. I'll just have to erase it and start over. But 8x, x squared minus 8x minus 9 equals 0. X squared minus 8x minus 9 equals 0. And now, again, use your quadratic formula. So negative b plus or minus the square root. B squared minus 4ac all divided by 2a. So we plug in everything. We have a equal to 1, b equal to negative 8, and c equal to negative 9. So a equals 1, b equals negative 8, c equals negative 9. So b, that's a negative 8. Plus minus the square root of b squared, which is going to be a negative 8 squared, minus 4 times 1 times negative 9. All divided by 2 times 1. All right, just plugs in all my a, b's, and c's. Now I'll clean it up a bit. The negative 8 becomes a positive 8. We'll have the square root. Negative 8 squared is a positive 64. And then 4 times 1 times negative 9 will be a negative 36, which minus and negative become plus 36. So be careful about the minus and negative number will become a plus number. Your calculator will give you that if you're careful about it. And 2 times 1 is 2. So if we just add the 64 and 36 together, this will become 8 plus minus the square root of 64 plus 36, 100, all divided by 2. And so the square root of 100, this is convenient because it's a perfect square. That value is just 10. So we have 8 plus 10, or 8 plus and minus 10 over 2, which again you can separate. You can have 8 plus 10 over 2 and 8 minus 10 over 2, which 8 plus 10 will become 18 over 2, which results as 9, right? Because 18 divided by 2 is 9. 8 minus 10 over 2, 8 minus 10 is a negative 2 over 2, which simplifies into just negative 1. So we have a 9 and a negative 1, which is E. Alright, and I think that's going to be about it, guys. I hope I didn't take it off too long. It's 10 questions. Same ones I think you'll see on the PowerSchool test. So hopefully you do better on it. And I will see you later. Hopefully, this helps. Alright, sayonara.